change one Airtable automation. It looks fine. Then, the next day, 3 other things quietly break. A timestamp stops updating. A Slack message fires twice. A record lands in done without the required fields. You end up diffing automations you didn't even touch because the rules are spread across too many places. That's not bad luck. That's a system with hidden rules. What you want is one predictable gate, one place where every status change is evaluated the same way. In this build, we'll collapse dozens of fragile Airtable automations into one Airtable trigger, feeding one n8n dispatcher. Then, you push the actual work into transition-specific subworkflows. If you stay with me, you'll leave with a dispatcher blueprint you can reuse. A transition map that defines what status changes are allowed, guardrails for illegal jumps, protection against double runs, and an audit log in Airtable so you can answer quickly who changed what, when, and what ran. Here's the mental model shift. Before you had many Airtable automations, each one watches some condition. Each one updates some fields, some overlap, some conflict. Some assume another automation already ran. When you add a new rule, you duplicate logic. When something breaks, you hunt. After you have one trigger, it fires on a status change every time. That event goes into the same dispatcher. The dispatcher decides what transition just happened, validates it, and routes to exactly one subworkflow that owns that transition. Statuses stop being labels. They become controlled checkpoints. Think of a simple lifecycle. New, in progress, blocked, review, done, archive. Now, you decide what moves are allowed. New can go to in progress. That's allowed. In progress can go to blocked. Allowed. Blocked can go back to in progress. Allowed. In progress can go to review. Allowed. Review can go to done. Allowed. Done can go to archived. Allowed. And then you explicitly mark what is not allowed. New to done is blocked. Review back to new is blocked. Archived back to in progress is blocked. This is where most Airtable setups fail quietly. The rules exist, but only in people's heads or scattered across automations. So the system can't enforce them consistently. Once you have that map, the dispatcher becomes straightforward. Airtable triggers, n8n receives the record ID, it reads the current status and the previous status, or it reads from and to if you store both. Either way, you need 3 inputs that are always present: record ID, from state, and to state. If you can't reliably know the from state, your dispatcher will guess. And guessing is how you get phantom behavior. So the dispatcher takes those inputs and looks up the transition in your map. If it finds a match, it routes to the corresponding subworkflow. In progress to blocked calls one subworkflow. Review to done calls a different one. Each transition has a single owner. If it does not find a match, you do not try something. You stop, and you write down what happened. The guardrail behavior should be boring and consistent. Mark the run as rejected. Log the attempted from and to. Log who requested it, if you have that context. Then choose one operational response. Option 1 is passive. You leave the status as is, but you log the rejection and notify a channel. That's useful when humans are exploring and you don't want the system fighting them. Option 2 is corrective. You revert the status back to the from state. That's useful when downstream effects are expensive and you need the table to remain valid. Either way, the key is that illegal transitions become visible events, not silent corruption. This is the payoff versus Airtable automations. You get one place to change the rules, one place to debug, and you stop duplicating the same if status equals X, then update Y logic across dozens of automations that drift over time. Now, let's make it safe in production, because routing alone isn't enough. The failure mode you'll hit next is duplicate runs. Airtable can fire twice. A user can toggle a status back and forth. n8n can retry after a timeout. Webhooks can be delivered more than once. If you don't protect against that, you'll send duplicate emails, create duplicate tasks, or overwrite fields with stale data. So the dispatcher needs an idempotency check. You generate a transition key that represents this exact transition event. At minimum, it includes record ID, from state, and to state. In practice, you'll also need something that distinguishes two legitimate repeats over time. That can be a timestamp from Airtable's last modified time, or a revision counter you maintain, or the automation event ID if you have it. The point is that the key should be stable for the same event and different for a new event. Then you look it up before doing any work. The simplest place to store this is an Airtable transition log table. One row per attempted transition. The dispatcher searches for the key. If it already exists, you exit early. No side effects. You can still log that it was a duplicate if you want, but you don't run the subworkflow again. If you skip this, you will eventually debug a "why did this run twice" incident. And you won't like the answer, because it's usually because distributed systems. Now, inside each transition subworkflow, you want a single source of truth update pattern. Meaning, the subworkflow that owns review to done updates everything that must be true when something is done, not just the status. Also, the done timestamp. The owner field entry changes. Any derived fields. Any linked records. Any notifications. You do it together in one controlled place, so you never get partial updates from multiple automations racing each other. This is where relief shows up operationally. You stop wondering which automation sets which field. You know where the truth lives. Now, the audit log. If you want this to be maintainable, you need a paper trail you can filter. In that transition log table, store fields that answer real debugging questions. Record ID, from state, to state, requested by. If you can capture the user or integration, the n8n run ID, the subworkflow name you routed to, started at, finished at, outcome like success, rejected, or error, and the error message if there was one. That gives you three things you don't get from scattered automations. You can validate behavior, you can diagnose failures without guessing, and you can hold the system accountable when someone asks, "Why did this record move?" Put together, the system becomes predictable. Validation prevents illegal jumps. Idempotency prevents duplicates. Logging makes failures diagnosable. And the subworkflows keep field updates consistent. As you add states, you update the map. As you add transitions, you add one subworkflow. The dispatcher stays stable. Here's the full loop end-to-end. Airtable triggers on a status change. The dispatcher reads record ID from state and to state. It checks the transition map. It blocks or allows. It runs an idempotency check. It routes to the correct subworkflow for consistent multi-field updates. Then, it writes an audit log row back to Airtable so every transition is traceable. The scaling question is what happens next when you keep adding rules. If you let the dispatcher accumulate business logic, it becomes a giant workflow no one wants to touch. So keep a hard boundary. The dispatcher does routing and validation, nothing else. All business logic lives inside the transition-specific subworkflows. The audit log remains your debugging and accountability layer. That's how you scale operations without brittle, duplicated Airtable automations and without running into automation limits. If you're implementing this today, use this video as a checklist. Write your states and allow transitions. Build one dispatcher in n8n. Move each transition into its own subworkflow. Then add idempotency and a transition log in Airtable.